If one throws a mango straight up in the air, that mango will go up and then back down. With that information, one could calculate its total y displacement and the total time it spent in the air. To do this, you need to start with your known values. The y acceleration as it leaves the tosser's hand is negative 9.8 meters per second squared. And as it reaches its peak, its final y velocity is 0 meters per second. This is because as it goes up, it slowly slows down until it reaches the peak, where for a split second it has no velocity before continuing downwards and gaining velocity. Once you have this information, you then need Vy initial. Then you can solve for t. You can obtain Vy initial by using an app like vidanalysis. Once you've obtained t, you can then plug it into this equation to get your total y displacement. Now, when we did this experiment and we tossed our mango up and then down, we only measured from when the mango left the tosser's hand. Therefore, here, when it's leaving the tosser's hand, is the point of origin. So when we're measuring displacement, it's only from here to its peak height, and when we're measuring time, it's only from when it leaves the hand to when it reaches the same distance. Using the data we obtained from vidanalysis, we were able to make a graph, and we put in a line of best fit. From that line, we were able to find its y-intercept, and we used that for our Vy initial, which was 5.6 meters per second. We then plugged that into this equation and found the change in time from when it left the tosser's hand to where it reached its peak. That was 0.571 seconds. We then multiplied that time by 2 to find its total flight time, which was 1.14 seconds. We then took that number and plugged it into this equation to find its y displacement of 1.60 meters. Then, as you can see by the graph, we looked at our experimental data and found that we had a change in time total of 0.9 seconds and a change in y of 1.39 meters. We then calculated our percent error for both change in time total and change in y. For our change in time total, we got a 27% error, and for change in y, we got a 15% error. This is because our y-intercept that we used for Vy initial was higher than any of our actual values. This then kind of skewed our time calculations, and because time is necessary to find displacement, that then affected this.